from point A, right? So basically we have here new, right? So in the new mode, what's going to happen? So every single process that's coming from the application layer, basically it will be assigned a unique ID, PID, right? And then what's going to happen next is that once your process has a unique ID, the next stage it is going to be what stage? What was the stage name? Exactly. What was the stage name after the new? Ready. So it was the ready. Why? Because once you have a unique ID, now it is time you need to assign somewhere, right? So you need a short-term memory. So you need a short-term memory to save this process, right? So that's why your PCB, or it is also called like process control block, it's gonna give some memory to store every single process. All right? So the next thing what's gonna happen is that once you have a unique ID, and then once you have a memory to store the process, the next stage it is going to be
Running.
So basically it will be inside the CPU, right? So it will be running, right? Inside the CPU. And then, so like 2 weeks before, what we learned is that we basically learned 8 algorithms of the CPU, right? CPU scheduling algorithms. So basically, okay, we basically, in week number 5, what we learned is that we learned 8 algorithms to see how your CPU is going to handle the jobs, right? And it was divided into 2 parts, if you remember, preemptive and non-preemptive algorithms, right? So like first come first serve, round robin, so shortest job first, so 8 algorithms. So this is week number 5, this is what we learned. And then the next, starting from week number 6, what we learned is that once the process has some kind of I/O request, what is gonna happen? It is gonna go to wait. So basically it's gonna go to the wait also. So you can also refer it like wait system call, right? Wait system call, right? And then the problem is, it will start having some problems. So what kind of problem you might have? The problem that you might have is that once the process is gonna come right here, and then if it has some kind of I/O request, it is gonna go to the wait system call, right? So inside the wait, what we learned, like even yesterday, is that if we have 2 processes, let's say process number 1 and process number 2, and then let's say this is going to be a hold, this is going to be your wait. So what's going to happen is that if your process number 1, so it is happening inside the wait, okay? Inside the wait. If process number 1, if it is holding right now, let's say some kind of resource A, and then if it's waiting right here for the resource number B, and you have another process that arrived to the wait, and this process, it is holding B, and it is waiting for resource A. So, and then we have what? We have a deadlock, right? So deadlock is gonna happen. So we have process number 1 is waiting for the process number 2. Process number 2 is waiting for the process number 1, right? It's like circle loop. So we have something called deadlock, right? So this is what we learned last week. So deadlock is gonna happen. And then the problem is these 2 processes is going to stuck inside the wait forever, right? Unless you're gonna kill this process. So you need to call what? You need to call kill system call to for example, to kill one of the processes. Once the process number 1 has been killed, right? You have available now, you're gonna take is available resource and you're gonna give it to the process number 2, right? So by killing one of the process, you're basically making the chain so run. So after the wait, what's gonna happen? After the wait, the process is gonna come where? Is it gonna come to the new or is it gonna come to ready? Okay, why it's not gonna come to new?
After killing?
No. So let's say process has been like executed, right? So once after the I/O request, now after the wait, now process needs to go somewhere, right?
Yeah.
So where is it? It's going to go where?
It comes to ready.
It comes to the ready? Okay. So please raise your hand if you think it is gonna come to the new. Nobody, right? Okay. It is gonna come to the ready. See?
No, I think it's you.
Why?
Okay, why?
You think it's special?
Просто. Because.
Because
Нормально,
ChatGPT так
просто
сказал.
скажите, зачем. I'm gonna explain you. So the problem is that it is going to come to the Reddit. So the problem is that once the process has been assigned a unique ID, that's it. You cannot change it. So there is no logic after the wait. It should come to the new. There is no logic because you will not override the ID, right? So the problem is, but you need another memory. So you need another memory to hold the new coming process, right? And after this one, your process control block, it's gonna send it to the heap. So that's why if you're like in the lab, we are going to learn. Once you call wait system call, the address of the process is going to change. Okay, the address of the process is going to change. So, and then we also learned, for example, we learned basically the graphs, right? How to find out the deadlock and what is deadlock, and like, so this is going to be the circular stuff. It's going to be what? It's going to be your process, and the rectangular is going to be your resource, right? So if the edge is coming from the, so let's say if it's coming from the process to the resource, we call it request edge. If it is coming from the resource to the process, we can call it assigned, right? This resource has been assigned to this process. So we're gonna call it assignment edge. So now we are going to learn something new, and it is called Banker's algorithm. So the problem is that a group of scientists, they came, and then they, for example, they were thinking, all right, so if the process are coming and if they're waiting here, while waiting, they might get deadlock, right? So why don't we apply some kind of algorithm right here or here, like between like this point? Why don't we apply some kind of algorithm so that once the CPU is, before sending to the wait, it is gonna check, is it safe to send the process or it is not safe, all right? So people, they come up with Banker's algorithm. So before sending request to the wait, first they want to apply to the Banker's algorithm so that it is going to be safe, so that we can avoid the deadlock, all right? So you might ask how we can avoid the deadlock, right? And then the Banker's algorithm is gonna come. So let me explain you Banker's algorithm. It is good? So the Banker's algorithm, it is gonna be something like this. So by the definition of the banker, you can like, Banker's algorithm exactly works like banking system, right? So let's say it is going to be your bank, right? So let's say this is your bank. And then you have, let's say, 4 people coming to take money, to borrow some money, to apply for the loan. You have person number 1, you have person number 2, you have person number 3, and then you have person number 4, right? So overall, just imagine bank as your operating system, right? Just imagine it as your operating system. And then you have 4 people coming to borrow some money from the bank, right? So let's say your bank right now, let's say it only has 10,000 sums inside the bank account, right? And then the person number 1, it wants to borrow 7K, this one wants to borrow 4K, this one wants to borrow 3K, and this one wants to borrow?
10.
No, it cannot borrow.
2K.
Okay, let's say 11. It doesn't matter, let's say 11. Let's say 11. Why not? So, and then what's gonna happen is that your Banker's algorithm, it's basically, it will be right here, all right? So it is basically gonna be here, it is going to check. Before sending it to the wait, it's gonna check. Is it safe? Before sending the money, it's gonna ask how much you want. So it is asking, okay, I want 7K, right? So in that case, Banker's algorithm, what's gonna happen is that to avoid the deadlock, if it's gonna say yes, P1, it only remains how much? 3,000 left, right? And then when it comes to the P2, it has no money, right? The bank has no money because it gave the 7K to the first person, now it only has 3K in the bank account, right? So basically, we're having shortage of the money, right? And the shortage of the money, you can refer like your deadlock, right? Because this person number 2 is gonna wait for P1, right? So we are going to have a deadlock. So to avoid this one, what bankers gonna do is that first, they are going to check, all right, instead of giving this person 7K, why don't I first gonna give some money to this person, person number 2, because it's only once like 4K, right? And then next, I'm going to give the money, so let's say P2, right? And the next, after that, I'm gonna give 3K to this person, P number 3, right? So, and next, now I only have 7K, right? So it has been 7K. Now, what I'm going to do is that, I'm gonna wait a little bit. Once these people, they return the money back, and then I'm going to run process number 1. So next, I'm going to run process number 1. Alright. So by doing that, process number 1. So by doing that, your bank basically allocated more money, right? Allocated more money. The same logic applies for the banker's algorithm. So the banker's algorithm, first it is gonna give some money for this person, and once this money, return the money back, and then it's gonna give the money to the first person, all right?
They return.
And the last one, it's simply gonna reject it,
Wow.
all right? So let me explain right now, like in more detail for the banker's algorithm. Okay. So why do we need banker's algorithm? So we need banker's algorithm for one reason, to make sure that we're going to send the process and these processes will not get stuck, all right? So basically there will be no deadlock. That's why to avoid the deadlock, we are going to apply the banker's algorithm right here so that you don't have any kind of deadlock, right? So this is the main reason. So banker's algorithm, it's gonna, we need this one to avoid the deadlock, and then we need to have some kind of safe state. So this is going to be our safe state, all right? First allocating the money to the second person, and then the third person, and once they return the money back, and then we're gonna give the money to the first person, and then we're going to reject this one. So this is our safe state. Safe sequence, you can also call it, okay? Safe sequence, right? So, in very short, banker's algorithm is gonna work in very similar way how your banker is gonna allocate the loan to make sure, and it's gonna ensure that they can still satisfy all the customers without running out of the money, okay? So this is banker's algorithm. So the problem is gonna come like this. Okay, the purpose is the same, okay? To avoid the deadlock, to avoid situation like this, okay? To avoid situation like this. So now let's solve some practice. Let's do some practice. All right, the practice is, okay, let me do some practice. I will erase this side, okay? Do you want me to write this one or this one?
Just because.
Okay. Right. So we have right now process number 1. We have process number 2. We have process number 3. Process number 4, process number 5. And then we have allocation. I told you guys allocation, you can just refer it like hold, right? Hold, just say allocation. Allocation, hold. The next is going to be max. And then available. We can write available right here. Guys at the back, is it visible?
Yeah.
It's visible, it's good. So we have 0, 1, so 0, 1, 0,
2 0 0
0, 0,
3 0
3, 0, 2,
2 1 1
2, 1, 1,
0
0, 0, 2. And then the next one for the max it is
7 5
3,
3
3, 2, 2. Okay, so we have 7, 5, 3, 3, 2, 2, 3, 2, 3, 2, 2, 9, 0, 9, 0, 2, 4, 3, 3. And then the available is 3, 3, 2. So this is going to be your matrix, okay? So this is going to be matrix. So what it basically means is that from resource A, resource B, and then resource C. So the same for this one, resource A, resource B, or resource C. It doesn't matter, 1, 2, 3, or ABC, it doesn't matter, right? So let's count all the resources first, right? How many resources we have? From the resource A, how many you have?
5.
Why 3? We have 3 types of resources. Resource A we have. So P1 it is holding only resource B, right? And your process number 2 it is holding only 2 copies of the resource A. Your P3 it is holding 3 copies of the resource A and then 2 copies of the resource C. If you want to find out array, simply 2 plus 3 plus 2. 2 plus 3 plus 2, all. We still have available. So available, it basically means in the bank, we still have 3 resource A, 3 resource B, and then 2 copies of the resource C. Okay, does it make sense? Resource B, and this is going to resource C. Okay, so this is in the bank. So this is everything, for example, 5 people right now, and this is how much money they're holding from the bank, they borrowed from the bank, and this is the account of the bank, okay? So right now, 2 plus 3 plus 2 plus, and we have available in the bank, how many? 3. Just count. 10, 10, right? Next, we are going to count RB. So from the resource B, so process number 1 is holding only one copies, right? And then we have process number 4 plus 3. So in total we have 2, 5. And then let's see resource C. So resource C, how many? 2, 1, 2, 5. 5 plus 2, 7. And in total, 10 plus 5, 22, right? So in total, inside your bank right now, you have 22 resources. Okay, 22 resources. So in allocation or hold, it basically means the process, how many, like, what it is holding, okay? And then we have another matrix. This matrix is called max. So the reason why it is called max is that the maximum, process number 1 can only handle maximum 7 copies of resource A, 5 copies of resource B, 3 copies of the resource C. What does it mean is that if you will go to the bank and then you apply X amount of money, right? You're gonna apply for the loan, right? But before applying to the bank, you need to have an asset so that bank can take that asset in case if you don't return the money, right? So bank right now has overall so many resources, right? And this person number 1, process number 1, the maximum amount of money it can get from the bank is this one, okay? Right now it is holding these resources, but the maximum it can take from the bank, it is 7 copies of RA, 5 copies of RB, 3 copies of RC. And person number 2, it can only, the maximum amount it can take from the bank is 3 copies of RA, 2 copies of RB, and 2 copies of RC. Yeah. Okay, any questions so far? Нету, да? Понятно. And now we need to find need, right? And we need to find need. So finding the need is super easy. You simply take the max and okay, so the maximum it can apply 753, right? And it is holding only 0, 1, 0, right? So the difference between the maximum it can apply and right now how much it is holding is going to give us need matrix. So it will be basically max minus hold. Hold, okay?
Yep.
So 7, okay, I don't know why, but so a student from another group, they simply taking 753 and then it's subtracting 10 and then it's writing down 743 right here. Right? So this is not right, okay? So this is the matrix. So RA 7 and then R0, RA it is 0. So it is going to be 7. 5 minus 1, 4, 3 minus 0, 3. And for the process number 2, 3 minus 2, 1. Okay, 1, 2, 2. And this one is 6, 0, 0. The next is going to be 0, 1, 1. The next is
4, 3, 1.
So we simply found right now need matrix, right? Need
What
matrix.
if allocation is more than max?
If okay, this is good. This is good. So allocation, it basically means how much right now that person is having resource, right? And the maximum is how much it can maximum request, right? I mean, it has no logic. It has no logic. I'm gonna explain why. Because right now you have 10,000 money, but the maximum you can apply for the bank is maximum the money you can get is 7,000. It can never happen, right? So the max, so the difference between max and whole, it should be always positive,
Yeah.
right? And now we are going to come. We are going to come to the real problem. Now we are going to apply Banker's algorithm. So what Banker's algorithm is going to tell you is that it is basically going to say if the need of the any I, for the I it is 1, 2, 3, 4, 5, okay? The need of the any process is less or equal than the work. So for here, just remember work is the same as available, okay? Then you need to update the balance sheet. So what it means is that, okay guys, is it visible?
Yes.
Is it visible? Alright. So we are going to come and then we are going to do the same job for the P1, for the P number 1. So we are coming right now and then apply the Banker's algorithm. So we need to check need of the first process. Is it less or equal to the work? For us, the work is this one available, okay? 3, 2. Понятно? What is the need of the first person? The need of the first person is 743. So 743. Is it less or equal to this one? No. So it is no. So if this is true, then we are going to update the work, okay? If this is false, just ignore it, okay? First, again, we are going to go and then we are going to check for the second person. So for the P2, the need of the second.
1, 2, 2.
Okay, what is the need of the second process?
1, 2, 2, 2.
1, 2, 2, right? 1, 2, 2. Is it less or equal to the work?
Yes.
Okay, 3, 3, 2, right?
Less.
Okay, 1 is less than 3, 2 is less than 3, 2 is equal to the 3, right?
Yeah.
So even if one of the numbers are not true, everything is not true, okay? So this one is correct, right? So now we found the first process. So the first process that your Banker's algorithm is going to send to the weight, okay? So I'm going to write it right here. So P2. First it is going to be P2. Correct? So since this condition is true, since this is true, now we need to update the work, okay? Update the work. So let me explain. So here the work, it is basically means the stuff available, okay? Available. What's gonna happen is that if the process is gonna get approved, then this process number 2 will get executed. And now you have to update your balance. You have to update the balance. To update the balance, you basically gonna take the current balance and then you're going to add the hold, okay? So a good example for this one is that, right now, somebody borrowed from you 4,000, right? And right now you have 10,000, somebody borrowed from you 4,000, right? And then it is gonna return your 4,000. Now how much you have? 10 plus 4, the same. Once this person is going to return the money, now you have to update the balance. So to update the balance, what you're gonna do, you're gonna take your current balance, 322. You're going to take this one, 332, and you're going to add allocation of the second person. How much is person holding? 200. So right now our current balance is going to be 532. Понятно?
Yes.
Okay, did you get the idea?
Yes.
So basically what's gonna happen is that once the process number 2, it is inside the weight, right? So it basically means right now it will gonna execute it. So right now you have available resources of this one, right? So right now what you have overall inside the bucket, like inside the basket, how much money you have? So you have his money, the process number two's money, plus you're going to have all the available money. Now you're going to update your basket, okay? Your account. So now we are going to do this third one, okay? So this one is approved. Now we are going to come to process number 3. The process number 3, again, you're going to check the same. For the process number 3, first you're going to check the need of the cert. What is the need for P3? The need is 600. 600. And then check, is it less or equal than the current balance? What is the current balance right now? So this is going to be our current balance, 532. So just let me just, what is going to be our available balance? Right now it is 532, right? Right now it was this one, now it is 532. So is it less than 532?
No.
The person is asking, the answer is no, right? So this person will get rejected from the bank,
P4.
right? So since this condition is not true, do not update your account, okay? Now you're going to come for the P4. So to find P4, guys, is it visible right here?
Yes.
Visible?
Yeah.
Okay. So now let's do P4. So to find the P4, first we are going to do if the need of the 4,
Less or
if the
equal.
need of the
Is less.
if the need of the 4 is less or equal to the current balance. What is the current balance?
532.
532, right? Is it less?
Yes.
Yes, right? So it is approved, right? So since the condition is true, now update your current balance. So you're going to take 211 plus 532. Now you available balance is
743.
532 plus
211.
211, right? It will be 743. 743. Понятно?
Yeah.
Now it is going to be 743. 743. So P4, it is true, right? So next thing is going to be P4. Okay? Now we are going to check P5. To check the P5, just check the P5. We are going to check the need of the P5. 431. 431. Is it less or equal to the balance? 743. The answer is
Yes.
yes. So you need to update your balance. Now our available is how much?
954.
Okay, it's going to be 002 plus this one, right? So 745.
5.
Now it is 745. Okay. So V. This one is next. So next it's going to be P5. Right? Okay. So once we finish this one, again you're going to come and then check the process number 1 and number 3. Because once these people return the money, maybe now we can afford to give a loan to these remaining 2 processes. Okay? So to check, okay, I need to remove something. I will. Guys, can I remove this side?
Yeah.
Okay, let me remove this side. Okay, so. And then we are coming again to the 6, right? So we are gonna come to the first again. Process number 1 again. Now we are going to check what is the need of the process number 1. The need is 743, right?
Yes.
743.
Less.
And what is our account balance? It is 745. So basically now your bank can afford to give money to the first person, right? So basically you're going to update your account. What is now available?
010.
745 plus
010.
755. Понятно?
Then we have
So now it is going to be P1.
P1.
Now we need to come and check the third person, right?
Yes.
So what is the need of the third person?
600.
600. 60. Is it less or equal than 755?
Yes.
So it means your bank is going to give the money. And you need to update your balance. So now the updating balance is going to be how much?
300.
755 plus 303. It's going to be 10, 0, 5, 10, 5, 7.
7, yes.
10, 5, 7. So this is your account right now.
Yes.
So this is your account right now, right? And then the consequence we are going to get this one. So it is a bit like complicated, but the problem is if you by applying Banker's algorithm first, if you're going to send P2 to the weight, and then if you're going to send P4, and then if you're going to send in this sequence, you're not gonna get any deadlock. Ayana?
Yes.
A bit complicated, but overall. And one more thing, this is how you can check the balance. So in the very beginning, how many resources we have? 22, right? And right now, check your balance. 10 plus 5 plus 7. 22.
22.
So overall, in the end, you have 22, and in the beginning, you had 22.
Yes.
Easy.
But I have a question.
Uh-huh.
Why would you say sequence check if P4, then P1, then P3?
No, we're gonna. I will fix it. I'll fix it. Okay. I think it's another problem. Guys, any question?
No. No questions.
If in the midterm I'm gonna give you.
This is easy.
Easy. Practice tomorrow, right?
Easy.
We'll start a practice tomorrow.
Yes.
Okay.
We'll have a 3 lecture. 2 lectures.
Lectures.
Yeah, Friday.
Yeah, bro. I mean, we have a lot.